Hello everyone and welcome back. So in this video I want to do a quick walkthrough of the curriculum and talk about what to expect from this course. This course explains the concepts from basic to advanced, so it's advisable not to miss any section before you go to the next section. The very first section is introductory section, in which I explain basic content such as what is data structure, what is algorithm, and why we need them. Then the next section is called recursion, which is really important stuff. So this is used in many algorithms. So it's very important to learn it before diving into the deep data structures and algorithms, because it comes up late on in many of our algorithms. And there are lots of interview questions about recursion, and main ones are explained in cracking recursion interview question sections, which is our next section. Then the next topic is big O notation. It is the way of describing or talking about the performance of efficiency of code. So we use this section all the time, so definitely do not skip that. And there are many interview questions that are related to big O. So the most asked questions are explained here in the section of cracking big O interview questions. Then we move on to the next section called arrays, in which we explain different types of arrays such as one-dimensional array, two-dimensional arrays, and we have introduced how they are represented in memory, and we have calculated time and space complexities for array operations. The next, we shift over to talk about Python list, which is very similar to the arrays, just a small difference, so we explain the differences between them. Then we analyze the interview questions related to arrays and Python list. Then from here, we continue to explain built-in data structures of Python, which are dictionaries and tuples. And we have analyzed these data structures by using big O notation to calculate the performance. Then we continue to the longest section of this course, which is called linked list. Here, we have covered all details of linked list with performing all operations on different types of linked list, such as single linked list, circular single linked list, double linked list, and circular double linked list. You will never find such detailed information on any other course on the internet about linked list. Additionally, we have explained famous interview questions about linked list in a separate section. Then we move on to do two more additional data structures, which are stacks and queues, and these are very commonly used data structures, and here also common interview questions are explained about them. Then from here we start another very detailed section which describes whole tree data structures, in which we include binary tree and the main concepts of binary tree, such as pre-order traversal, in-order traversal, post-order traversal, and level order traversal. So here again we recall things like big O notation and recursion. Then from here we continue to do binary search tree and then AVL tree. In AVL tree we have covered important concepts like left-left condition, left-right condition, right-right condition, and right-left condition. And we have implemented these conditions in inserting or deleting a node in AVL trees. This is a fun section in my opinion, because there are a lot of challenging problems that we are doing over here. Then we are going to the binary heap, which is related to trees, but a very special case of tree. And we talk about common operations of binary heap. And finally, we go to the last type of tree, which is trie. The trie takes characters as a node, so it's very useful, especially when developing applications like dictionaries. Then from here, we go to the hashing section. So here we talk about a very particular data structure, which is very interesting. So here we explain how Python built-in data structures work and how they are implemented behind the scenes, and how would you implement a key value pair data structure by yourself. So from here, we get to the sort of second part of the course. Up until this point, we have been talking about different types of data structures. But from this section, we will start to talk about different types of algorithms. So from this slide to the end of course, we will talk about different types of algorithms, which are very essential concept of computer science. So we move on to the sorting algorithms, in which we will learn 7 different sorting algorithms. We start with bubble sort, which is often considered the easiest one. And we move on to the selection sort, and then we move to the insertion sort. And those three form a little group of intermediate or elementary sorting algorithms. Then we move to the bucket sort, then merge sort, and then quick sort. And these sorting algorithms all involve recursion and big O notation. That's why it's very important not to skip those lectures before you come over here. Then we finish up this section with heap sort. Then from here, we go to the another detailed section which is called graph algorithms, something that a lot of people are intimidated by. So here, first we start to explain graph data structures and show how to implement them using Python. Then we continue to implement graph algorithms like breadth first search, depth first search, which are used in graph traversal. Then we continue to find topological sort for a given graph. Then from here, we will continue to solve problems like single source shorts path problem and all pair shorts path problem. So we will solve these problems using 4 different algorithms such as breadth first search, Dijkstra's algorithm, Bellman-Ford algorithm, and Floyd-Warshall algorithm. And we will also talk about why we cannot use depth first search algorithm for these problems over here. Then from here, we will continue to the minimum spanning tree, which is special type of graph. And we will solve this problem using 2 different algorithms like Prim's algorithm and Kruskal algorithms. Then with this, we conclude the graph section and we move on to the next section, which is called greedy algorithms. So here we talk about which algorithms use greedy approach, and we solve problems like activity selection problem, coin change problem, and fractional knapsack problem using greedy approach. Then the next section is divide and conquer algorithms. Here I will talk about main properties of divide and conquer algorithms, and we will learn how can we identify and solve problems using divide and conquer approach. Then we will solve problems like number factor problem, house robber problem, convert one string to another string, zero knapsack problem, longest common subsequence problem, longest palindromic subsequence or substring problem, minimum cost path problem using divide and conquer approach. And we will create methods in Python for those problems over here. And from here we will continue another detailed section which is called dynamic programming. I know many people are curious about learning dynamic programming. So here I will talk about main properties of dynamic programming such as optimal substructure property and overlapping subproblems property. Then we will learn 2 methods of dynamic programming which are top-down with memoization and bottom-up with tabulation. And I'll show you 4 steps to convert divide and conquer algorithm to dynamic algorithm. Then we will continue to learn common problems that can be solved using dynamic programming such as number factor problem, house robber problem, convert one string to another string problem, zero knapsack problem using dynamic programming. So after this section, I have created a challenging dynamic programming exercises section for those who like pain and misery, because these are quite hard problems. So if you are interested to solve hard problems in dynamic programming, you can continue with this section over here. Then finally, we will reach the Wild West section, which includes coding exercises for all topics that we have explained in this course. So that is where we finish this course. But this is not the end, because I'm in process of recording new sections based on your requirements. And more sections are about to come. So hopefully you will enjoy the course. So see you in the course.